Hello everyone, I am Mike. As you have known, I am a Udemy instructor specialized in the utility and energy industry. Now in this video, I am going to provide you with a mini course on medium voltage switchgear fundamentals. Now I'm going to try a new method in teaching for this mini course. With this mini course, I will be your guide, where I will teach you about medium voltage switchgear and referencing other videos on YouTube as we progress. My aim is to get you the knowledge you need by using my material as well as other YouTubers' material to maximize your learning experience. As such, you will see that at multiple points of this video, I will direct you to watch another YouTuber's YouTube video. Now, when that time comes, please refer to the YouTube links in this video's description and click on that said video link. Now, I recommend you to use a computer for this course, as when prompted you to view another video, you can pause this video, right-click the link that I recommend you to watch, and view it in a new tab on your web browser. Then you should close that tab once you are finished and resume this course video. So now let me be your guide in this medium voltage switchgear learning journey, and let's get started. So now let us start off with the fundamental question of what is a switchgear? Well, a centralized collection of circuit breakers, fuses, and switches that safeguard, regulate, and isolate electrical equipment is what is referred to as electrical switchgear. Now in this case, metal frameworks house the circuit protection devices, and a switchgear assembly is a grouping of one or more of these metal framework. Now, switchgear may be found in a variety of places, including electric utility transmission and distribution systems, as well as medium to large commercial and industrial buildings. Now, IEEE defines the electrical switchgear standards in North America, and the IEC would be the one that defined those in Europe and other areas of the world. Now, the medium voltage switchgears that we focused on in this mini course are switchgears that are of voltage levels that are 2.4 kV to 69 kV, and kV meaning kilovolts. And there are around six general types of medium voltage switchgears that are available. And these are the metal-clad switchgear, the metal enclosed switchgear, the arc resistant switchgear, the pad-mounted switchgear, the vault subsurface switchgear, and the gas-insulated switchgear. So now let us start off with the metal-clad switchgear, which is defined by IEEE C3720.2. Now, this is a medium voltage electrical switchgear in which all electrical components, including the incoming bus, outgoing bus, instrumentation, and main circuit breaker or switch, are enclosed in separate metal compartments for added safety, ruggedness, and ease of maintenance. Metal-clad switchgear has rated voltage ranging from 5 to 38 kilovolts. Metal-clad switchgear is commonly used in industrial facilities as well as electrical power generating and transmission facilities because it has draw-out circuit breakers for easier maintenance. Now, the second type that I want to talk about is the metal enclosed switchgear, of which the IEEE C3720.3 specifies. Circuit breakers, power fuses, and fusible switches, as well as control and metering equipment, are all contained in metal enclosed switchgear. These devices can be installed in common compartments without the need for separate barriers or compartmentalization that metal-clad switchgear requires. Where the incoming electrical service is usually above 480 to 600 volts, 480/600 volts, metal enclosed switchgear is used in commercial as well as many industrial installations. Now, the third type that I want to talk about is the arc resistant switchgear. Traditional switchgear isn't built to resist the massive amounts of energy emitted during an electrical fault. Thus, arc-resistant switchgear is designed to contain and deflect arc flash energy away from the operator in a safe manner. And this is usually done by channeling arc flash energy via a plenum to a location where it may be discharged without endangering persons or equipment. Now, these specifications are defined in the IEEE C3720.7. If you want to learn more about arc flash in general, I do have an arc flash fundamental course in Udemy as well. Next up is the pad-mounted switchgear. IEEE C37.74 specifies this type of switchgear. Now, pad-mounted switchgear is designed for subterranean distribution systems with a voltage range of 5 to 38 kV that must be operated above ground. Pad-mounted switchgear is appropriate for utility distribution, feeder sectionalizing, and circuit protection applications because of its outside-rated low profile and tamper-resistant design. To protect loads, isolate faults, and reduce outages, switches, fuses, and vacuum interrupters are often utilized. In a shared insulated sealed tank, pad-mounted switchgear with up to 6 ways is actually possible. Air, SF6 gas, fluid, solid dielectric in-air technology, and solid materials can all be used as insulation for this type of switchgear. Now, the fifth type of switchgear is the vault subsurface switchgear. IEEE C37.74 defines this type of switchgear. Vault or subsurface switchgear is designed for 15 to 38 kV electrical distribution systems that need the switch and its accessories to be operational from inside a underground vault or below grade area. These areas may be dry or prone to water intrusion. Vacuum interrupters are used to safeguard loads and isolate faults in vault or subsurface switchgear that allows the user to activate the switch from above ground manually or with the use of relays. SF6 gas, solid dielectric in-air technology, and solid or fluids are all examples of insulation methods. Now, the last type of switchgear that I want to talk about is the gas-insulated switchgear, or usually what we refer to as GIS in short. Now, these type of switchgears has sealed enclosures filled with insulating gas, which is often types sulfur hexafluoride or SF6, or a combination of SF6 and other recently released insulating gas that are being made. The gas-filled sealed container allows for low-profile, compact installation. So it is actually good when space is actually an issue for your design. Now, when compared to equivalent air-insulated switchgear, the use of gas as an insulating medium allows for shorter distance between interrupting components. Now, the ANSI IEEE standard C37.60 and C37.72 are used to design and test these gas-insulated switchgear. The gas-insulated switchgear was developed, built, and tested to International Electrical Technical Commission Performance Standard, or IEC 62271, prior to the IEEE C3720.9 for the GIS switchgear. So now let's go over nameplates. Now, a nameplate should be installed on all medium voltage switchgears. Manufacturer information should be included on the nameplate. The manufacturer's name, the type identification, and the serial number should all be included in the description of the switchgear in the nameplate. Nameplates should define also the ratings of the different compartments, especially if they are different, and most likely they will. Some of the information that should include, but this doesn't include the entire number of stuff that is included in the nameplate, as this differs by your switch type or manufacturer type. But they should include, nonetheless, things like the short circuit current, the continuous current, insulation level, insulation medium, enclosure type, the number of phases that it support, the operating frequency, as well as the various current and voltage ratings for the switchgear. For switchgears, there are various insulating mediums that we can use. Now, the most common ones are air, gas, mineral oil, and the E200 fluid. The most frequently used and least costly insulator is, of course, air. Air has the lowest dielectric strength, thereby necessitating physically bigger and more durable equipment to survive the impacts of, let's say, an electrical arc. When compared to air, gas insulation has a substantially higher dielectric strength. Sulfur hexafluoride, or more commonly known as simply SF6, is the most frequent gas utilized as a switchgear insulating medium. And with this insulating medium, the electrical connections are sealed by pressurized SF6 gas within a tank. Now, various fluids are employed for electrical insulation inside switchgear, transformers, and other equipment, despite the fact that they are commonly referred to actually as oil. It is critical that the fluid used is both fireproof and ecologically friendly. Now, two of the fluids that are commonly used for switchgears are mineral oil and the E200 fluid. Mineral oil is a time-tested petroleum-based insulator with dependable electrical insulating qualities. On the other hand, E200 fluid is a low-viscosity, fire-resistant, biodegradable polyester fluid with good dielectric, thermal, and physical characteristics. So now, let us look at the general list of components found within a medium voltage switchgear. Please pause this video and view the recommended video in a new tab and resume this video when finished with the other video. The link is in the video description titled Switchgear Components. So now please pause this video and view the other one before moving forward. So now, after looking at the different components within a switchgear, let us briefly look at the concept of an interlock. Now, mechanical interlocks, which were originally designed for high voltage applications, have been converted for use on medium and low voltage switchgear. Interlocks are installed on switchgear to lock it in the open or closed position, or both in some circumstances. Now, after the switchgear has been actuated, the key is released and the process moves on to the next interlock. The state of the key gives physical verification of the switchgear's working condition, and the interlock mechanisms are simple, durable, and infallible. Interlocks may be adapted to practically any form of switchgear, regardless of size or rating, due to their simplicity of design. The most typical application is to prevent paralleling of incoming power supplies, which is accomplished by interlocking the bus ties with the incoming feeder switches. Each switch, 3 in total, has a mechanical interlock that locks the switch in the open position when the key is released. The key combination for each interlock is the same. The bus tie switch can't be closed if both feeder switches are closed, since only 2 keys are needed. It is feasible to guarantee that earth switches are closed only after the isolator has been opened using the same method. 2 locks with the same key combinations and a single key are utilized in this situation. Now, the operation of switchgears really varies depending on the type and manufacturer of the switchgear. So now let us look at an example of a switchgear operation. Please pause this video and view the recommended video in a new tab and resume this video when finished. The link is in the video description titled Switchgear Operation. So pause this video now and watch that particular video before continuing on with this course. So now we go over the fundamentals of a medium voltage switchgear. Let us now switch our gears to look at the maintenance side of switchgears. Let us first start with the typical inspections that we need to do. The typical inspections that we need to do include moisture and corona inspections, insulators and barrier checks, general wiring checks, general visual and mechanical inspections, moving parts and interlocks checks, as well as wiring and bolted connection checks. Let us start with the moisture and the corona inspections. Corona is most commonly seen in narrow air gaps between a high voltage bus bar and its neighboring insulation or between two adjacent insulating components in switchgear assemblies. Corona can also develop around sharp projections such as bolt heads that aren't adequately insulated or protected. Corona is almost non-existent in low voltage switchgear. However, though, there will be some risk in medium voltage switchgears. When completing maintenance checks, you should look for signs of moisture or corona. Roof or wall seams should be examined for indications of leakage on exterior components, and any leaking seams should be sealed with weatherproof caulk. You should also check for correct operation of all interior and outside lighting. And in the event of an emergency response or for other security concerns, it is critical that the area of where the switchgear is situated should be properly illuminated at all times. Next up are the insulators and barrier checks. Electrical stress on insulation causes tracking, which is an electrical discharge event. Now, this tension might occur between phases or between phases and the ground. Although certain insulating materials can track internally, these materials are rarely employed in medium or high voltage switchgear insulation. When tracking occurs in switchgear assemblies, it usually happens on the insulating surfaces. Physical damage or polluted surface on electrical insulators should be looked for. Corona erosion, marks, and tracking pathways are usually visible on the surface of insulating parts as a result of electrical distress. You should check for appropriate installation and operation of the barrier and shutter assemblies on the switchgears. All active components should be tested, and mechanical indicating devices should be checked to ensure proper operation. You should also make sure there are no obstruction in the vents and that filters are in place. To keep rats and small animals out, screens should be installed above ventilation apertures. Now, the third type of inspections that should be done are the general wiring checks. If the said wires are part of a key protective circuit, such as a circuit breaker's protective relay, loose control wires might cause catastrophic failures. If faulty connections warm and lose integrity, other vital operations such as electrical charging and circuit breaker reclosing may be hampered. To avoid damage during ordinary operation of moving parts, make sure all wire connections are tight and secure, especially when removing draw-out circuit breakers or opening and shutting cubicle doors. To establish and secure a connection, gently tug on the control wires or use a screwdriver to carefully test torque on the connection. Infrared scans can also be used to locate loose wires in the control circuitry. Now, the fourth type is just your general visual and mechanical inspections. For this, one should examine the switchgear or switchboard's physical, electrical, and mechanical condition, as well as its anchoring alignment, grounding, and needed clearances. Verify that the equipment nameplate data fits the project designs and requirements while performing acceptance testing if you are deploying or commissioning new switchgear. This is significant since switchgears are designed and rated for certain uses and should not be used for anything else unless the manufacturer has specifically approved of it. Now, the fifth type is moving parts and interlocks check. For this check, you should confirm that electrical and mechanical interlock mechanisms are working properly and in the right order. Locked open devices should be closed, while locked closed devices should be opened. Key exchanges with all devices involved in the interlock scheme, when relevant, are used to test key interlock systems, and all of these systems are critical for the operators and the equipment's safety. So be sure to check the interlocking system thoroughly. Finally, the last one that I want to talk about is the wiring and the bolted connection checks. A low resistance ohm meter, a calibrated torque wrench, or an infrared scan should be used to check for high resistance on bolted electrical connections. If these problems that you detected are not rectified, loose bolted electrical connections might result in greater energy usage and eventual switchgear failure. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed of the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career, as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineering consultant. By the way, that is where the actual money is. Now, I don't have these tools available for me when I first started my career. But now, PM Milestone has created this package of all of the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is in 2021. So they're not going to be out of date or out of context to the present times, as these people are serious in getting the most professional product to meet your business needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with what you are seeing. So if you're interested in this product and would also like to support me in creating more mini courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsored PM Milestone 2.0. So now let's move on into looking at switchgear testing. There are a whole variety of tests available pertaining to medium voltage switchgear. And in this course, I would like to briefly go over 3 of these, and they are the contact resistance test, the high-pot test, and the dielectric loss test. Now let us start with contact resistance testing, also known as the ductor testing, which is a method of determining the resistance of electrical connections such as terminations, joints, connectors, busbar sections, and cable connections. These can be any 2 conductor connections such as cable connectors or busbar sections. The ohm meter is the instrument that is used to do the ductor test, and because its job is to perform the ductor test, this is also known as the ductor tester. When contacts are touching one another, contact resistance is the barrier to current flow caused by surface conditions and other factors. This test is especially critical for connections that carry a lot of current, such as within the switchgear, because a higher contact resistance means a poor current carrying capability and resulting more losses. Contact resistance measurement aids in the detection of fretting corrosion of contacts as well as the diagnosis and prevention of contact corrosion. A high voltage drop in the system can be caused by an increase in contact resistance, which should be managed. Next up is the high-pot test. The phrase high-pot stands for high potential, which is short for a dielectric withstand test, which is the more technical term for high-pot testing. High-pot refers to a group of electrical safety testing devices. To guarantee that current flows freely from one place to another, high-pot testing is often required. The test checks the cable's integrity and its capacity to tolerate high voltages for a specific length of time. Testing ensures the reliability of cable assemblies and wire harnesses, which might be life-threatening if they fail. The safety and quality of all electrical circuits are ensured by good isolation between circuit sections. The high-pot test is significant because it determines the amount of electrical insulation of a device or assembly. The insulation's ability to withstand transient overvoltages, the push that causes electromotive charges to move in a wire or other electric conductor, is tested. Electrical insulation is subjected to high voltage over a lengthy period of time in order to ensure that it fulfills safety and quality criteria. The high-pot test identifies insulation defects by exposing the electrical insulation to transient overvoltages. It is critical to look for these problems. Insulation is frequently exposed to unpredictable changing surroundings or situation, which might have an impact on the equipment's functionality. Electrical insulation challenges in electronic harnesses and cable assemblies can be caused by braided shielding, stray wire strands, tolerance mistakes and corrosive pollutants, and even thermal spacing concerns. It may also be used to locate cuts in insulation as well as nicked or crushed insulation. The test is typically performed by connecting one end of the supply to the ground and the other end to the conductor being tested. A high voltage source or the ground might be used to join conductors. Simply ensure that your testing contact is separate from all other contacts is needed. And depending on the size of the tester, high-pot testers may measure anywhere from 5 to 400 kilovolts. And finally, we have the dielectric loss test, or also more commonly known as the power factor test. Dielectric losses, which are related to the wetness, dryness, or degeneration of electrical insulation, are measured using power factor test. The cosine of the phase angle between voltage and current is what we use to be called the power factor. The phase angle for optimal insulation is 90 degrees. In actuality, no insulation is perfect, and there is always some leakage, and the total current trails the voltage by less than 90 degrees. To accomplish this, we need to calculate the ratio of capacitive or charging current to resistive or leakage current to determine insulation power factor. Power factor testing is a method of determining the insulation's integrity, since the lower the power factor, the better the insulator. One of the most effective testing methods for predictive and preventive maintenance is this power factor testing. Without performing an inside visual check, power factor testing may also be used to uncover equipment insulation issues, and as a result, maintenance costs and downtime are significantly reduced with the use of power factor testing. And this last statement is a good intro to what I want to talk about next, which is maintenance, particularly preventive maintenance for switchgears. Mastering switchgear preventive maintenance is critical if your facility's requirements include safety, prolonging equipment life, or staying under budget. Here, let me walk you through the 5 most critical aspects of switchgear or medium voltage switchgear preventive maintenance. Now, nothing is more essential than your safety or your crew's safety. Therefore, learning how to properly isolate your equipment should always be your first concern. Now, determine if your system is a radio or double-ended or contain tie breakers. Then look for any backfeed concerns, which might be caused by a generator or someone else testing a transformer downstream that isn't properly separated. This is especially true if nowadays a lot of people use distributed generation technologies in the customer side of the distribution system. So backfeed is a real concern in this case. Now, many of your preventive maintenance choice may be guided by knowing what sort of environment your switchgear is in, which is essentially our second step. Is the dust on the switchgear from regular outside dust, smoke, or coal dust? Cleaning products and supplies such as vacuum filters and rags may be required for varied types and amounts of pollutants that your switchgear may be accustomed to in your environment. Waxing, for example, may be required if you have porcelain insulators. So you need to consult the manufacturer for the type of insulator that's being used and what type of maintenance it needs. If the insulators are epoxy based, then lint-free cloths and alcohol is enough to clean these insulators. Furthermore, chemical vapors may be more prevalent in some environments, which can quickly corrode metallic parts, especially within switchgears. So make sure to document your switchgear equipment with photos and pay attention to its physical condition. If you notice that silver-plated parts are corroding or discoloring badly, infrared scans may be required to check that no hotspots are forming within your switchgear, which they might actually lead to a catastrophic switchgear failure in the future if they're not properly attended to. Now to our third step, which is to follow procedures. Basic procedures for each type of switchgear that needs to be maintained, such as whether or not if it's a metal clad or pad mounted switchgear, should be in place at the very least. Also, you should inspect if there are any surge arresters or PTs or CTs, as well as bolt tightness and insulating coatings should be considered specifically if they are present in that specific switchgear. Test of voltages for using high-pot or mega testing, as well as if there are any electromechanical or digital relays being used within the switchgear. They should also be a part of the procedure to follow for testing or for your maintenance. Find out also, one of the most important things that you should do is to find out the lubricant that's being used by your switchgear. In a sense, you should also look at what the actual brand that you used also. Because the thing is, different brands and manufacturers have different kinds of ratio of the fluid that they used. And employing the wrong product would void the warranty of your switchgear, as they are usually maybe less effective than the materials used by the manufacturer of that said switchgear. Now next, we should develop a good maintenance plan. You should make a timetable on how frequently you will do preventive maintenance on your switchgear. And this considers factors such as the criticality of the equipment, its condition, and the kind of switchgear it is. These are only suggestions, but they are a good place to start when it comes to creating an efficient preventive maintenance plan. Reliability and uptime, if proper PM is used or preventive maintenance plan is used, will rise, and the total cost of ownership will significantly reduce if you maintain your equipment on a schedule that minimizes the impacts of the wear and tear, as well as the environmental conditions that it is in. You should check the instruction manuals that came with your switchgear to determine if there are any specified replacement schedules that are dependent on the usage and the age of the switchgear. However, though, this type of determining when switchgear should be replaced or properly maintained is difficult with old equipment, because often parts is quite expensive or scarce for these old equipments, and retrofit may not be actually available. So you might, in this case, you might need to do a redesign to actually accommodate for a new switchgear for replacement. And finally, make sure to prepare detailed reports for your switchgear preventive maintenance and thoroughly review these reports. Now, this is arguably the most underappreciated aspect of a successful preventive maintenance plan. Most people only search for problems in the item list that have been highlighted or identified. Potential problems can be recognized long before failure or service interruption if you actually looked at the reports and the test data and track the trends of these results. And this saves time and money in replacing or in terms of reactive maintenance, which is a type of maintenance when failures actually occur. And this, of course, will also keep your working crew safe from potentially catastrophic situation. Now, all in all, it is good to keep all of these maintenance plans in-house, but I would also recommend you or your business to check with a third-party preventive maintenance business to see if the test reports that you have with these equipment, because they are actually quite different depending on which vendor that you use. So it would be good if you could consult with these third-party companies to see if you can make these test reports be formatted to be more uniform, and to make the trends detected be simpler to monitor. And you should also be diligent and have a team to thoroughly check the results of these tests to make sure that your switchgear has the best preventive maintenance that it needs to prolong its life, as well as to make sure that if any inherent condition that it has, it should be detected early on in its development stage. And this brings us to the end of this course. I hope you enjoyed this mini course and have learned a lot about the medium voltage switchgear. As I have mentioned in the beginning, I wanted to try out this new format for materials that I want to teach you, which I wanted to offer you for free. If you like more of this, please let me know in the comment section below. Also, medium voltage is often referred to distribution voltage, which belongs in the distribution system. And if you want to learn more about the distribution system, I recommend you to take my Udemy course titled Distribution Power Engineering Fundamentals, which I left the link in the video description below. Again, thank you, and I hope to see you in my other courses in the future.